Welcome to our session on advanced venting systems in plumbing. Today, we are going to explore the specific code requirements for wet venting, circuit venting, and stack venting, and understand exactly why these rules exist to keep our plumbing systems safe and functional. Let's start with wet venting. A wet vent is a highly efficient design where a single sanitary drainage pipe does double duty. It carries waste from some fixtures while simultaneously acting as an air vent for others. However, to prevent the pipe from choking, you can only have a maximum of 2 wet-vented water closets, and they must always be installed downstream of all other fixtures. If your design does include 2 water closets on a wet vent, they have to connect at the exact same level. You would use a double sanitary T fitting if the vent is vertical, or a double Y fitting if it's horizontal. The code also restricts horizontal offsets in the wet vent to maintain smooth airflow, limiting them to 1.2 meters for smaller pipes and 2.5 meters for pipes larger than NPS 2. Next, we have circuit venting. This is a technique heavily used in commercial settings where you have a row or battery of fixtures on a single horizontal branch. Instead of running an individual vent to every single toilet, a circuit vent connects to the branch itself. The main rules here are that all fixtures must be on the same story, and no vertical drainage stack can connect upstream of your circuit-vented fixtures. To keep the air pressure perfectly balanced in a circuit-vented system, you must install a relief vent downstream of the very last fixture. Furthermore, if your horizontal branch gets complicated, for example, if it changes direction by more than 45 degrees, or if you have more than 8 fixtures connected in a row, the code requires you to install additional circuit vents to ensure the system can breathe properly. Now, let's shift our focus to vertical systems, specifically vent pipes for stacks. Every single drainage stack must terminate at its upper end in a stack vent. But as buildings get taller, the rules change. If your stack drains fixtures for more than 4 stories, the volume of falling water creates massive air pressure fluctuations. To handle this, you are required to install a dedicated parallel vent stack. For really tall buildings, those over 11 stories, the engineering gets even more rigorous. You must install yoke vents, which tie the drainage stack to the vent stack every 5 stories to relieve trapped pressure zones. Also, if your main stack has a horizontal offset longer than 1.5 meters, you might need an offset relief vent to prevent the pressure from blowing out the trap seals in the fixtures above. To wrap up, remember that all venting is fundamentally about protecting trap seals by managing air pressure. Wet venting safely combines waste and air for a few fixtures. Circuit venting efficiently handles horizontal rows of fixtures, and stack venting manages the intense vertical pressures of multi-story buildings. Understanding these concepts is key to designing safe, code-compliant plumbing systems.